quick review on simplifying radicals. When you simplify radicals, you need to factor out all perfect squares. Now our perfect squares are 4, 9, 16, but you don't really have to worry about 16 because it's just 4, 25, 36, 49. You probably won't go beyond 25. You may use 100 occasionally if your answers are in, or if your square roots are in the hundreds. You might be able to factor out 100. So let's do an example. The square root of 108. The first thing I'm going to do is ask myself, is 108 divisible by 4? And my calculator will tell me, why, yes. Yes, it is. It factors into 4 times 27. So now I have the square root of 4 times the square root of 27. 4 is my perfect square. I'm done with that. So now I look at 27. And I ask myself, does 27 have any perfect squares? And I start with 4. Is 27 divisible by 4? No, it's not. And so I move to my next perfect square, 9. Is 27 divisible by 9? Why, yes. Yes, it is. 9 is a perfect square. So I factor it out. It's 9 times 3. So now I ask myself, are there any perfect squares in 3? And no, there are not. So I have factored this into the square root of 4 times the square root of 9 times the square root of 3. Then we just do the math. 2 times 3 times square root 3. 2 times 3 is 6, square root 3. That is simplest radical form. Now, some of these problems you will run into might have variables. Let's look at perfect squares of variables. Squared means you multiply something by itself. We're going to use x's. We like those better. X times x is x squared. X squared times x squared is x to the 4th. When we multiply exponents, we add them. So x cubed times x cubed is x to the 6th. X to the 4th times x to the 4th equals x to the 8th. Now you should notice something here about all of your perfect squares on your exponents. They're all multiples of 2. So if we have something like x cubed and we are square rooting it, we know that we could factor this into x squared times x, because there's a little invisible 1 there. 2 plus 1 is 3. And this would simplify. Square root of x squared is x, square root x. For chapter 10, you are also going to need your special right triangles. Now you remember we have our 45, 45 right triangles. We said those were isosceles. And we have our 30, 60, 90 right triangles. Our 45, 45, we can label these as x, x, and x root 2. We also have a formula that says the hypotenuse equals the leg times the square root of 2. Now the formula will always work, but if you have one of these legs, You know it is x, you simply substitute it into the hypotenuse. On our 30, 60, 90 triangle, we need to label our legs. We need to know where the short leg is across from the short angle, our 30-degree angle. We need to know where our longer leg is across from our 60-degree angle. And of course, we need to know where our hypotenuse is. Then we know short is x, hypotenuse is 2x, and long is x root 3. We also have formulas for these. We know that the hypotenuse is 2 times the length of the short leg, which is exactly what your formula says, 2x. If your short leg is x, then your hypotenuse is 2 times x. And we also know that the long leg is the short leg times root 3. Again, your formulas will always work, but if you have the short leg, you can just substitute in, and if you have the hypotenuse, you can divide by 2 and substitute in. So make smart choices on those. If your special right triangles don't work, you always have SOHCAHTOA, and don't forget our friend Pythagorean theorem, a squared plus b squared equals c squared, where c is always the hypotenuse, and trig. Trig will always work. You will need all of these items to be successful in Chapter 10.